So Fourier series means any periodic function fx of period 2 pi which satisfies certain conditions, and that conditions are called as Dirichlet's condition. Dirichlet's condition. So I'll tell you what that is. Dirichlet's conditions can be expressed as a series A0 plus summation n equal to 1 to infinity an cos nx plus bn sin nx. Then this is called as Fourier series. Okay, means any periodic function. Now go term by term. Yesterday while the presentation somebody explained periodic function. So periodic function means that if you can express, say, if f of x plus nt, if this is equal to f of x, then such functions are called as periodic functions. Here if you noted this one, see here, see, sin 2n pi plus x is sin x, cos 2n pi plus x is cos x. Means when you add 2n pi with the sin x and cos x, you are getting the same function again. Okay, so here the sin x and cos x, they are periodic functions. Means if you are getting the same function, once you add something, then that is called as period. Means it repeats, like in periodic table. In periodic table, you know, first element, then it combines sodium, hydrogen, helium, lithium, beryllium, like that. When you say, when you go, so after this one, third element, it comes 11th element, then 19th element, means first group element you are getting there. Now, first group element, when you say that it repeats after a certain number, and here you can see the properties are almost same. First group element, the properties are same. Second group element, the properties are almost same and all. So it repeats, the property repeats after a certain number, certain period. Similarly, if you look at the music, when you say sari gama pada ni sa, so after 7 letters again it is going, it is it is repeating. Okay, so such functions, when functions are repeating like that, such functions are called as periodic functions. Means it repeats after a certain period. Say for example, now every Thursday 10 to 11 you have maths lecture. Your first period is, or Thursday first period is this one. Means it repeats every Thursday after 8 days or after 7 days, it repeats again. So now today it is second. So after the, means the 8th day, after 7 days, you are going to have the same lecture. And the 9th of December, 10 to 11, you will have the same lecture. So after a certain time, it repeats again. So like that, after a certain angle, if a function repeats again, such functions are called as periodic functions. Say for example, if I say sine 2n pi, so sine 360 plus 30, this will be sine 30. Okay, because after sine 30, we know where it is. So here 0 to 90, 90 to 180, to say 270, 360. Okay, now after 360 again, what happens here? It is 360 here. So 360 plus 30 means it comes here. 360 plus 30, that is in the first quadrant. So again you are getting sine 30 there. Okay, so it repeats after 2 pi. Similarly, if I say sine 720 plus 30, if we say sine 720 plus 30, this is also going to be sine 30 only, because this is what, this is 360 into 2, or 2 into 2 pi, 4 pi it is. So 2 times 360 is this one. So it is again repeating, means after each 360 angle the value, the function sign repeats itself. Okay, so such functions are called as periodic function, means after a certain time it repeats or the function remains the same. So in short, if we say f of x plus nt equal to f of x, then we can say the function is periodic function for n equal to 1, 2, 3 like that, where t is the period there. Okay, t is the period. Then, so any such function, so the first condition for Fourier series is the function should be periodic. Okay, it must repeat after a certain time interval. Time interval in the sense after a certain angle and all. Then of period 2 pi. So here the period must be 2 pi. That means here the t must be 2 pi, means if I say sine 2 pi plus theta is sine theta, then after each 2 pi, so here it must be sine 4 pi plus theta, this will be sine theta. Then sine 6 pi plus theta, means after each 2 pi, after each 2 pi it repeats. So that is a periodic function. So here the period is 2 pi. After each 2 pi it repeats, means here the period is 2 pi. So that period must be 2 pi, which satisfies certain conditions. That conditions are called as Dirichlet's conditions, and if it satisfies that condition, then this function, whatever function we consider, that can be expressed as a series like this. Okay, where a0, an, bn, these are given by some formula. So that is a0 plus, means simple thing is, if sinus is a small function, you can write this as sum a0 plus sum of n equal to 1 to infinity a1 cos 1x plus a2 cos 2x plus a3 cos 3x plus etc. Means this small function will be expressed as a very big function, as a series. Okay, it can be expressed as a series. So then that we call, that series we call as what? Fourier series. Okay, while doing one question you will get to know what it is, how to write that. So now what are Dirichlet's condition? So Dirichlet's condition means, this is sometimes this used to come as a theory question, Dirichlet's condition. So the Dirichlet's conditions are, first one is that is normally we define, say, a function f of x defined in the interval, defined in the interval C1, C2. Now I hope you remember last time we discussed there are 4 types of interval. I am not going deep into that. This is closed interval 0, 1, say C1, C2. If I consider 0, 1, then we have, this is open interval. Then we have closed, open, या semi-closed. Then we have like this, semi-closed, this can be called as semi-closed or semi-open, like that you can call, or you can say closed open, open closed. So these 4 kinds are there. I hope you remember. If it is closed interval, you can consider these 2 values while calculating. Then if we are considering open interval, means these 2 values will not be taken for calculation, and means this symbol means we can take that value also while doing problems. Okay, so I am not going deep into that. So here we define this in the interval C1, C2, then can be expressed as a Fourier series in this interval if it satisfies this condition. So Dirichlet's condition, I will tell what it is. The first condition is that fx and its integrals are finite and single valued. Firstly, I'll write this, then I'll explain this example. Fx and its values are finite and single valued. Second is fx has finite finite discontinuities in the interval. And third condition is that fx has finite number of maxima and minima. Okay, this is Dirichlet's condition. That means fx and its integrals are finite and single valued. So that is very clear. The function should be finite and it must be single valued. Now finite means you know what it is, and single valued means, say for example, single valued, to tell that, say if I consider sine inverse 1 by 2 or sine inverse 1. If we consider sine inverse 1, means you know there are so many angles for which sine is 1, like sine 90, sine pi by 2, sine 90 is 1. Okay, then we have sine 5 pi by 2, this will be 1. Then sine 9 pi by 2, this will be 1. If you have doubt in this one, just look at the your calculator or something, because sine 90 is 1, sine pi by 2 is 1, sine 3 pi by 2 is minus 1, sine 5 pi by 2 is plus 1, like this. So sine then 9 pi by 2 will be plus 1, so like that it will go on. So here if I say sine inverse 1 is pi by 2, then here if I say sine inverse 5 pi by 2, sorry, sine inverse 1 is 5 pi by 2. That means we are getting so many values of the angles for which sine is 1. Then it is not single valued. Okay, single valued means there must be only one value for that particular function. Means, say for example, if I consider f of x equal to x square plus 2 in the interval 0 to 2 or closed interval 0 to 2, then here this f of 2 will have only one value, like 2 square plus 2, that is 4 plus 2 6. This is single valued function. Okay, f of 2, so if I consider say f of 0, then only 0 square plus 2, that is 2. If I consider any value between that, say f of 1 if I consider, then 1 square plus 2 3, means only single value. These are single valued function. But here if you consider sine inverse 1, when you consider, you can have pi by 2, 5 pi by 2, 9 pi by 2, like that it will go on. Means this is not single valued function. I hope you understood what is single valued function. Means you must have only one value for that particular function. So if sine inverse x is, if you want to find the Fourier series of Fourier exponent of sine inverse x, then it is not possible in a particular interval. Means that depends on the interval also, but otherwise also sine inverse x you cannot express as Fourier series, because it is not a single valued function. Okay, so that is the first line, first condition meaning. Okay, now the second condition is that fx has finite discontinuities. Finite discontinuities means, say for example, if I say f of x equal to 1 upon x minus 1 in the interval, say 0 to, okay, in the interval 0 to, here if you look at this one, 0 2 means you can have the value for x as x equal to 0, x equal to 2, and any value like between 0 and 2. And we know between any two numbers, any two natural numbers or any two real numbers, there are infinite number of numbers are there. Okay, infinite number of real numbers, rational numbers are there. Infinite number of rational numbers are there. So between the 0 and 2, if you are looking, then 0 0.01, 0 0.001, so like that infinite number of numbers are there. Okay, so among that one, if you consider x is equal to 1, So when x is equal to 1, this is 1 upon 1 minus 1. What happens? Here 1 minus 1, if you consider 1 minus 1, then this function is not continuous here. 1 upon 0 comes here. Okay, so 1 upon 0 comes there, that means the function is not defined. The function is not defined. But if I consider, instead of this one, if I take x minus 1, then at x minus, out of so many values, at x minus, at x equal to 1, the function at f of 1 equal to, this is 0, means the function is going to be discontinuous there. Okay, then